Let's look at the solutions of number system bytes. A and B start working simultaneously at 9 a.m. A works for 10 minutes, followed by rest of 4 minutes. B works for 15 minutes, followed by rest of 2 minutes. What is the first time they would be resting simultaneously? For exactly 1 minute. Resting simultaneously for exactly 1 minute. Pay attention, not in the first minute where they are resting together, but when they are resting together simultaneously for exactly 1 minute. Okay, look at the behavior of A. He works in the first minute, second minute, third minute, fourth minute, so on and so forth. He keeps on working till the 10th minute, but he doesn't work in the 11th, 12th, 13th, or 14th minute. So can I say, whenever A is not working, the time will be either 14n plus 11 or 12 or 13 or 14n itself. If these are the minutes, if these are the number of minutes, then A would not be working. Let's look at behavior of B. B works for 15 minutes, followed by rest of 2 minutes. So first 15 minutes he works, 16 he doesn't work, 17 he doesn't work. He doesn't work 17k plus 16, or he doesn't work 17kth minute. Now, because the question says they are simultaneously working for they are simultaneously resting for exactly 1 minute, either it would be his last minute and his first minute, or his first minute and his last minute. One of these two cases has to work. So let us check. In the first case, 14n plus 11 is equal to 17k, or if I can break it down, 14n plus 11 is equal to 14k plus 3k. So I need a number which is a multiple of 3 and also 14n plus 11. I can see that k has to be 13. 17 into 13, this will be 221. And this will be 14 into 15 plus 11. Or the time that would have elapsed is 3 hours. 3 hours and 41 minutes past it. 3 hours and 41 minutes past the 9 o'clock starting time. So it will be option B according to that. It will be option B according to that. But this does not mean this is the answer. Let us check the other case. This one here now. 14n is equal to 17k plus 16. So 14n is equal to 14k plus 14 plus 3k plus 2. So 3k plus 2 has to be a multiple of 14. Okay, k has to be 4. So the timing we are looking for is 68 plus 16, 84 minutes. This will be 14 into 6, not a problem. So basically 1 hour and 24 minutes hence from the starting time. Of course, this is earlier. The question was asking first time they would be resting simultaneously for exactly 1 minute. So 1 hour 24 minutes wala range. So it will be the 10:23 a.m. to 10:24 a.m. this time range. They would be resting simultaneously for exactly 1 minute. Next question. All 3-digit numbers in which the 10th digit is a perfect square are formed by using the digits 1 to 9. Okay. The sum of all such numbers is, because you're only using digits 1 to 9, that helps us. A potential area of concern here could be whether 0 is a perfect square or not. Yes, 0 is a perfect square, but we don't really care for it because we are only using digits 1 to 9. How many numbers will get created? Let us see. This blank can be filled in 9 ways. This blank can be filled in 9 ways. Just to pay attention, this is also 9 ways, this also 9 ways. 0 is not possible. So 9 ways, 9 ways, 9 ways, 9 ways. All together, there are going to be 243 such numbers. 243 such numbers. Now see, what comes to our aid in calculating the sum here is the distribution of numbers. Can you see all the numbers that come here? All the numbers that come in the leading digit place, they will come equal number of times. There is no distinction there. There is no discrimination there. Every number would have come 1 to 9, digits 1 to 9 would have come there equal number of times. So can I say contribution to the grand summation of the leading digit would be 243 by 9 into 100, the placeholder value, into summation of all the individual digits, 1 plus 2 plus 3 plus 4, so on and so forth, up until 9. Okay, now looking at the tens digit, we have 243 numbers, and each of these cases would come equal number of times. So 243 by 3 into 10 into sum of 1 plus 4 plus 9. And finally, for the unit digit, we would get 243 by 9 into 1 into 1 plus 2 plus 3, so on and so forth, plus 9. So basically, we have 27 into 45 right at the end. We have 27 into 100 into 45 right at the beginning. And we have 81 into 10 into 14 in the middle. Three very, very irritating products, but okay, let's try. 27 into 45. I don't know, but 13.5 into 90. Okay, 13.5 into 90, 135 into 9. 135 into 9 would be 1215. Okay, so I've got 1215 followed by 2 zeros for the first product, and therefore for the last product I also have 1215. This is also known. Now for the product in between, 14 into 8 is 1120 plus 14 is 1134. 1134 followed by a 0, so 11340. Okay, let's add it up. I've got 5, 0, 1 carried over, so 4, so 3, so 1. So answer to the question is 1,34,055. The answer to the question is 1,34,055. Next question. Mr. Srinivas was able to find the two natural numbers, both greater than 1, as soon as their product was told to him. No other information was given to him. What would be the product of the two numbers if it is greater than 40 and their sum is 16? Good thing here, look at this number. If there is any number, you will always have a pair of 1 into n. If you try to represent it as product of two numbers, you will always have this pair 1 into n, and you will have other pairs. Given that this is product of two numbers, of course you will have other pairs. So I'm saying let it be a into b. If a and b are prime numbers, this would be the only pair that exists. If a and b were not prime numbers, you will get other cases also. Test casing, let us do it for 21. You would have 1 into 21 and you would have 3 into 7. No other pairs exist. But if you are doing it for 28, you would have 1 into 28. You would also have 2 into 14. You would also have 4 into 7. Can you see? If these two are prime numbers, then you will not have any other cases. But if these two are not prime numbers, you will have other possibilities. And if other possibilities existed, Mr. Srinivas would not have been able to identify the two numbers. Basically, this is a long drawn way of the question telling us that these two numbers are necessarily prime. We are also told their sum is 16. So I have to look for two prime numbers that add up to 16 and their product is greater than 40. Let's see. I will check the two prime numbers by checking prime numbers under 16. 2 and 14, would it work? No, these are not two prime numbers. 3 and 13, yes, these are two prime numbers, but their product is 39. So this wouldn't work. Let me check with 5 and 11. Yes, it meets all criteria. Summation is 16. Product is greater than 40. Everything is done. If you have the understanding of what a theta question is, given that you found one case, this should be your answer. But in case you want to be comprehensive and go ahead and check, 7 into 9, this is not a prime number, so wouldn't work. Additionally, one more thing, you don't have to check anymore. If you have checked all the numbers thus far, can you see after the halfway point, the cases are going to repeat themselves in reverse. And given that we don't really have a placeholder value here, we don't have ordered pairs to consider here, you don't need to check anymore. The answer to the question will be 55. Next, let T be equal to 2, 12, 22, blah, blah, and blah. And S be a subset of T such that the sum of no two elements of S is divisible by 3. The maximum possible number of elements in S is. Okay. Given I'm looking for divisibility by 3, it would be ideal to represent these numbers in families of 3. The first number is 3n plus 2. The second number is 3n. The next number is 3n plus 1. The fourth number is 3n plus 2. The next number 42 would be a 3n sort of number. The next number 52 would be 3n plus 1. Can you see? Every group of three numbers will contain such divisions, every group of three numbers. And given we have 56 numbers. Remember, 56 numbers, not 58. Sorry, not 55, 56, because we are moving from 02 to 552. Forget the last two, 0 to 55 is 56 numbers. Can you see? If it is 50, had it been 57 numbers, you would have had 19, 19, 19 everywhere. Had it been 57 numbers, it would be 19, 19, 19. All three would have been equally distributed, but because it is 56 numbers, we would have 19 3n plus 2 kind of numbers, 19 3n kind of numbers, and 18 3n plus 1 kind of numbers. I want the maximum possible number of elements in S, and no two elements of S should add up to a multiple of 3. Now see, if I took a 3n plus 2 kind of number, can I take any more 3n plus 1 kind of number? If I took a 2, can I take a 22 anymore? Not really, not possible. So as soon as I select one of these groups, these two groups, the other group is completely out of bounds. I cannot select that anymore. The problem inherent here is, which group do I select? Of course, the group that has the greater population. Let me have all numbers 2, 32, and 62, and 92, and all of these numbers. This will go up till 542. How many elements do I get? I get 19 elements from here, but this will not be the answer. See, I don't want the sum of two elements to add up to be divisible by 3. Can I add one additional element from this group? Say, let me take one multiple of 3 here. Let me take 12 here. Now, even if I pick up any two numbers within this list, will the summation be divisible by 3? Of course, it will not be. And therefore, that is perfectly all right. The answer to the question is 19 plus 1, 20. Okay. Last question. In how many ways can 183 be expressed as sum of two natural numbers that are co-prime to each other? Okay. If two natural numbers are co-prime to each other, see how the working would work. Let's say the two numbers are HA and HB. And let's say these numbers were not co-prime to each other. If these numbers were not co-prime to each other, can you see whatever HCF they had, it would also be a factor of 183. Whatever HCF they had would also be a factor of 183. So can I say I have to remove those HCF, those possible HCFs that are factors of 183? Factors of 183 are 3 and 61. So I have to remove all multiples of 3. I have to remove all multiples of 61. So how many numbers under 183 are co-prime to it? This is given by the Euler expression. 183 into 2 by 3 into 60 by 61. Cancel, cancel. I get, there are 120 numbers. There are 120 numbers under 183 that are co-prime to it. There are 120 numbers under 183 that are co-prime to it. But 120 is not the answer. The answer is, see, we have 120 numbers, but we need pairs of numbers, because it is how many ways in which we can represent 183 as sum of two natural numbers which are co-prime to each other. It would be like this. See, 1 plus 182, 2 plus 181, 3 I can't do, 4 plus 179. Can you see? As soon as you identified one co-prime number, the other co-prime number is the complementary number. Similarly, 5 plus 178, 6 I can't do, 7 plus 176, so on and so forth, you would keep on doing. So given that you've identified 120 numbers co-prime to 183, there will be 60 pairs or 60 ways in which 183 can be expressed as sum of two natural numbers that are co-prime to each other. Hopefully you learned something. That will be all for this episode.